Before we begin, make sure you watch this video all the way to the end, because what you're about to hear might completely change how you imagine planets in the universe. Imagine standing on a world where the ground beneath your feet is not rock, not sand, but glass, not smooth, polished glass like a window, but jagged, shifting, endlessly reshaped by storms so violent they can strip landscapes in hours. Now imagine that the sky itself is filled with shards of glass, racing sideways at thousands of kilometers per hour, slicing through anything in their path. This is not science fiction. This is a real type of world scientists believe could exist. A planet made of glass storms. Welcome to a place where the weather doesn't just change the environment, it destroys it. To understand how a planet like this could even form, we need to leave Earth far behind and travel into the realm of extreme exoplanets. These are worlds orbiting dangerously close to their stars, so close that their surfaces are heated to temperatures far beyond anything we experience. We're talking about heat so intense that rock itself begins to vaporize. Minerals don't just sit still on the ground, they turn into gas and rise into the atmosphere. On a glass storm planet, the key ingredient is silicon, one of the most common elements in rocky worlds. On Earth, silicon is locked into minerals, like quartz and sand. But on a superheated planet, those same materials don't stay solid. They melt, boil, and eventually evaporate into thick, mineral-rich clouds. Now imagine those clouds cooling ever so slightly as they move to the darker side of the planet. The vapor condenses, not into water droplets like rain on Earth, but into tiny particles of glass. At first, they're microscopic, but as they collide and stick together, they grow into sharp, jagged shards, and then the winds begin, because these planets are often tidally locked. One side permanently faces the star, while the other is locked in darkness. This creates an extreme temperature difference, and that difference drives winds at unimaginable speeds. We're not talking about hurricanes. We're talking about winds that can exceed 7,000 kilometers per hour. Those winds pick up the glass particles and hurl them across the planet in a continuous, horizontal storm, not falling gently from the sky, but blasting sideways like a cosmic sandblaster. Except, instead of sand, it's razor-sharp glass. If you were somehow able to stand on this planet, you wouldn't last seconds. The air itself would cut through protective gear, erode surfaces, and shred anything exposed. The storm would sound like a constant scream, a high-pitched, grinding roar, as trillions of glass fragments collide and scrape against each other. But the surface is just as terrifying. Over time, these storms reshape the entire planet. Mountains are carved down, valleys filled in, and the ground becomes a chaotic mixture of melted, resolidified glass formations. Imagine dunes made of translucent shards, glowing faintly from the heat below. Imagine cliffs that look like frozen waves, formed when molten rock was blasted and cooled, mid-motion, and yet, despite the chaos, there's a strange kind of beauty here. When light from the nearby star hits the glass-filled atmosphere, it scatters in every direction. The sky might shimmer with unnatural colors, flashes of orange, deep red, and blinding white. Lightning could arc through the clouds, illuminating billions of spinning shards at once, turning the storm into a glowing, swirling prism. This is a world where even darkness isn't truly dark. The constant movement of reflective particles creates a faint, eerie glow, as if the planet itself is alive and watching. Now, here's where it gets even more fascinating. Scientists believe that on some of these planets, the glass doesn't just exist in the atmosphere. It can actually rain down, settle, and then be reheated and lifted back into the sky again, a continuous cycle. Evaporation, condensation, storm, deposition, and then back to vapor. It's a planetary system where geology and weather are the same thing. Think about that for a moment. On Earth, we separate the two. Weather happens in the sky, geology happens on the ground. But here, the boundary disappears. The sky is made of the ground, and the ground is constantly becoming the sky. Halfway through the video, if you're finding this as mind-blowing as it sounds, take a second to like the video, subscribe to the channel, and turn on the notification bell so you don't miss the next journey into worlds that feel impossible but are very real. Now, let's go deeper. What would it actually look like to witness one of these storms up close? At first, you might see a distant haze on the horizon, like a wall of shimmering dust. But as it approaches, the air becomes thick and distorted. Light bends strangely, reflections flicker everywhere, and the sky begins to lose its clarity. Then the storm hits. Not with rain, not with thunder, but with impact. Millions, billions of tiny collisions every second. The sound alone would be overwhelming, like standing inside a giant grinding machine. Visibility would drop to almost nothing as the air fills with high-speed particles, and the temperature wouldn't give you any relief. These planets are often hundreds or even thousands of degrees Celsius. The heat radiates from the ground, from the air, from every surface around you. It's not just a storm you can shelter from. It's an environment that is fundamentally hostile to anything we know as life. But here's an interesting question. Could anything survive here? At first glance, it seems impossible. But life on Earth has shown us that it can adapt to extreme conditions in ways we never expected. There are organisms that thrive in boiling water, in acidic lakes, even in environments filled with radiation. So could there be some form of life that has adapted to a glass storm planet? If it exists, it would have to be incredibly different from anything we know. It might not rely on water. It might not even have a solid structure. Perhaps it could exist beneath the surface, shielded from the storms,